Okay.
All right. In chapter 5 of elective mathematics, we are going to be looking at the quadratic functions. We are going to be looking at what? Quadratic functions. All right. Quadratic function. In commerce, we learn that any function that can be expressed in a form of f of x is equal to mx plus c, where m and c are constant, and m is never equal to 0. It's called, look at this, m is never equal to 0. That is it. It's called a linear function, okay? Because if m is equal to 0, it means that we'll be left with just a constant, okay? Good. It's
Okay.
called a what? A linear function. In this section, we shall look into functions of the form of, we're going to be looking at functions in the form of f of x, okay? And they are being given as what? You see what I'm writing on the screen? I'll urge you to also be writing it in your book somewhere, okay? Anything that you see me writing on the screen, take a pen and a paper and you also write. It's just like we are learning in class. So it is given in the form of what?
I tried it in a book.
Yes, write notes and be jotting down some important points. It's given in the form what? F of x
Okay.
squared plus what? Bx, okay, plus c. That is how quadratic functions are given us. I've taught you on the board before. I've taught you in class before, so I expect you should know better. Okay, so quadratic functions are given or are of the form of this way. Okay, ax squared plus bx plus c. Exactly. In this section, we shall look at functions of the form f of x is equal to ax plus bx plus c, which is the sum of terms involving a constant, and that is what c, x, and what s squared. They are the ones that we are saying that they are constant, because in every equation you are going to be saying c, x, and what s squared. So you should be taking note of some of these things. Okay, there are some things I won't write it on the board. I only say it with my mouth. You should be able to write all of them. Okay, exactly. Also, such functions are referred to as what? Quadratic. Okay, and such a function is referred to as quadratic. Okay, when you see the x to be squared, it is referred to as what? Quadratic function. So if I'm saying that this is a quadratic function, the one I'm writing with blue pen, I hope you can see the one I'm writing with blue pen. How will you call this one too? How are you going to call this function? Let's say mx plus c. If f of x is equal to mx plus c, how will you call this function? How will you call this function? This function, you call it a what? A linear function. I think I just taught you. I said it some time ago. Okay. So the one in the blue pen is a what? It's a linear function.
Linear.
And the one in the red pen that are circled is a what? It's a quadratic function. These are the two differences I want you to know. Okay. So you can take your blue pen and write somewhere. You write this and write linear function. And you come and write this one too and write what? Quadratic function. So that you know the difference between linear and what? Quadratic function. Okay, good. So I'm coming to be reading this, the one that I'm writing notes beside it. Okay. The one that I just wrote NB beside is where I'm going to be reading now. And I'm saying that a
Okay.
function is said to be quadratic if it can be expressed in a form of what? If it can be expressed in this form. Okay. A function is said to be quadratic if it can be expressed in a form of what? Ax squared plus bx plus c, where a, b, and c are constants, and a is never equal to 0. If a is equal to 0, what is the function going to become? Can you tell me what the function is going to become if this a over here is equal to 0? If a is equal to, I'm listening, please.
If the A is equal to 0.
Yes, if the a is equal to 0 in the quadratic function, what is the whole equation going to now become?
Constant.
Okay, you have tried. I will give you 1/3. But if you take a quadratic function, okay, and let's assume a is equal to 0, it means that the function is going to become a linear function. Do you understand? Look at this function over here. I want to solve this function for you to see something. Okay, my function, which is given as what? F of x. Okay, if a is 0, any number times 0 is what? 0. So if a
0.
is 0, you realize that the whole of here is going to be 0, and you are going to be left with what? Just bx plus what? C.
C.
So Look at bx plus c is not the same as the linear function.
Yes.
Exactly, exactly. So I can say that you are now becoming history. Okay. So this is what quadratic
Mhm.
functions. And I believe you have been taught linear functions in school already. Were you taught,
Linear function.
yes, were you taught linear functions in school? If,
Is it linear equation?
yes, it is the same as the linear equation.
Yes.
Uh-huh. So this one too, if you don't want to call it a quadratic function, how are you going to call it? Quadratic
This one.
equation. Okay.
Okay.
This one too, if you don't want to call it a quadratic function, you can either call it a quadratic equation. Good. So let's
Okay.
continue from 5.2. From 5.2 is trying to figure 5.2 is trying to tell us that maximum and minimum value and point of a quadratic function. Okay, that is in figure 5.2. We are going to be calculating for maximum and minimum value of a quadratic function, and that is generally what about, let me say, 80% of the questions you are going to be meeting in your examination or WASI entails. Okay, you are going to be doing the calculation of maximum and minimum value. Yeah, hello, you have a question to ask?
Please no.
Okay, so quickly read from the screen. If you can see my screen, kindly start reading. Maximum and minimum value. You can see I just denoted with that. We shall
Okay.
consider some, yes, start from that point and let me explain to you.
Maximum and minimum values and points of the quadratic function. We shall now consider some features of the quadratic curve. We shall later extend this idea to study the graph of other functions. Graphs, graphs and graphs of functions which are not linear poses certain shapes. Quadratic curves are parabolic in shape. The graph has two possible orientations. It opens upwards or opens downwards, depending on the coefficients of x squared. The function gives a minimum point when the coefficient a of x squared is positive. That is a less than 0, and maximum when it is negative. That is a greater than 0. The minimum value for y in figure 5.1 is -4, which occurs when x equals 1. It therefore follows that the minimum point of the curve is 1, -4. The curve in figure 5.2 gives a maximum point which occurs at 1, 4. It therefore follows that the maximum value of the function y is 4, which occurs when x equals 1. The
Okay.
minimum or the maximum point of a quadratic function is called the vertex or turning point of the curve. Using a completing of squares, every quadratic function f of x equals ax squared plus bx plus c can be expressed in the form f of x equals a into bracket x plus d squared plus k, where d and k are real numbers. The maximum or the minimum value of the function f of x occurs when x plus d equals 0. That is, at the point where x equals -d. It therefore follows that the maximum or the minimum value of the function is k. The following two examples illustrate how the maximum the bracket or the minimum point of a quadratic function is determined using completing of squares.
All right, all right. So thank you very much. So from what you just read, what is the conclusion you can draw? What have you learned that you can be able to tell me as a layman uh, to be able to understand this? Assuming a home economics student approaches you, a visual student approaches you, he doesn't know what limits of functions are. So how will you be able to tell the person to put him or her in her place?
All right. Now let's. hmm,
So all they are just trying to say is that what the function for the first one, okay, the function gives a minimum point, okay, when the coefficient a, okay, when the coefficient a of x squared is positive, okay. So when the coefficient is positive, you are going to get a minimum curve, okay? And the minimum curve is this one that is here that you are seeing. Okay, this is the minimum curve. And when the coefficient is what? Negative. When the coefficient is negative, okay? When the coefficient
Okay.
is negative, you are going to get what? A maximum curve. If I'm saying this, don't get confused, okay? An example of this equation could be in the form of maybe negative what? Ax what? Squared,
Good.
okay? Minus what? Bx,
Yes.
okay? Plus what? C,
Mm.
okay? And the first one, an example of such an equation, can you outline that to me to validate your understanding? This one, how is this one going to look like? This one, the questions are in the form of what? Just Ax. You see, it's just Ax. There is
Mm.
no negative attached to it. Ax plus what? Bx,
Yes.
okay,
I see.
plus C, okay. So if the coefficient of x squared is what? Is positive, it shows that the graph is going to be minimum. And if the coefficient of what? X squared is negative, it shows that the graph is going to be a maximum graph. Okay. And the vectors you were talking about is just the turning point. Okay. And the turning point, it occurs when x is equal to what? It occurs at what? X. Do you understand me? The turning
Okay.
point occurs at X. So we are just going to quickly take a question and see how best we can be able to apply that to be able to solve to make life much more easier. Let me just use this to explain this example for you. And I'm also going to use a different method to solve it for you to have these two method. At the end of the day, you tell me the one that you like. Okay. If
Okay.
I forget to ask you, remember me and let me ask. At the end of the day, I want you to tell me the method which you think is more suitable for use. Okay. All right. So the example one, they said, find, this is the example we are looking at now. Yes. It's saying that what? Find the minimum value of f of x. Find the minimum value of f of x is equal to what? 3x squared minus x minus 6 for the value of x and for what value of x does it occur. Okay, so they say you find the minimum value of this quadratic function and what value of x does it what. Okay, so over here, what did they write? First of all, they came to write the solution. You see, and what did they do? They repeated the question. Why did they repeat the question? Can you tell me the reason why they repeated the question? Hello? Hello?
Hi.
Please, can you tell me why they repeated the question in the book? Why did they repeat the question in the book?
You get 1 mark.
Thank you very much. So this should tell you something. Always you have to repeat the question to get, when you lose that mark, you are the one who is doing yourself. Then secondly, what are you going to do? You are going to factorize what? The coefficients, okay? You are going to factorize 3 out to make the coefficients of x to be what? 1. And that is what they did over here. In this step, when they factorize 3 out, you see what they had. I hope you get up to this step. Do you get up to this step?
So you said in the question you factorize
Yes.
the three.
The question that was given is what? 3x what?
Three, right.
Minus what? X minus what?
Minus 6.
6. So over here, they want to bring the common factor out. So when they bring 3 out, what are you going to be left with? You're just going to be left with what? X squared.
X squared.
Okay, and this one, what is this one going to be? This one is just going to be what? Minus what? 1 over 3. Do you agree with me?
Please, why?
Oh, because if you multiply this again, what are you going to get? You are going to get the same thing. Okay, don't get confused. Let me open your eyes now for you to see something. Do you agree that 3 over 3 is 1?
Yes.
So that is why that is happening. This one is going to be minus 2. So they just want to find a way to still make this coefficient to be 1. And it is 1 over, if you multiply this again, you realize that you get 3x squared minus what? 3 over 3x minus 6. So at the end of the day, 3 over 3 is 1, and that is still going to give you your original equation. Do you now understand what I'm trying to insinuate?
Yes, please.
Do you understand what I'm trying to say?
Yes, please.
So you understand how they got the second step that I just underlined?
Yes.
You have tried. Secondly, what did they do next? To further confuse you, they said that what? Divide the coefficient of x by 2 and square the result. So what is the coefficient of x from the relation? Next time, you are not going to be seeing this screen at all. It's just going to be a mere solution. Okay. So just grab this concept. We are going to take this same question and go back to see if we can solve without looking on the screen. Okay. So second, we should divide the coefficient of x. Divide the coefficient of x by 2. Okay. And the coefficient of x is what? Minus 1 over 3. So negative 1 over what? 3. Okay. Divided by 2. Divided by what? 2. So negative 1 over 3 divided by 2, what are you going to get? In the scientific world, this is
negative.
So in
negative 1 over 6.
Yes, in the scientific world, this is what is happening. At the end of the day, this is going to what? Interchange. So it's not going to become 2 over what? 1. It's now going to become what? 1 over 2 rather. It's now going to become 1 over 2. Okay. So it's now going to become 1 over 2 because it will interchange. That is why at the end of the day, they are getting the what? Negative what?
1 over 6.
1 over 6. Okay. So that is why they get the negative 1 over 6 over here from. So they say divide the coefficients of x by 2 and square the results. Okay. After getting the negative 1 over 6, what did they do? They came to square it over here. Can you see what I'm saying?
Yes.
Yeah. So they came to square it and they had what? Negative 1 over 6 or what? Squared.
Right.
Exactly. At the end of the day, what do you do next? At the end of the day, what did they do next? Tell me what they did. They add and subtract what? The negative 1 over 6 all squared to the expression in the bracket. Okay. So from there, this is what they came to do over here. I'm teaching you how to understand your own book. Okay. Yes. Even before I start to pick questions from it and solve. Okay. And this now from there, they came to this step. And this step, they say f of x. Now, wherever you see what? 1 over 3x, you are going to put what? Or even if you don't want to take that discovery, take this rather. They say divide the coefficient of x by 2, okay, and square the results. Okay, so the result, this is the result we have obtained. The result is what?
Negative
1 over 6 all squared. Okay, so you come and pick the quadratic function again. When you pick the quadratic function just as it is, okay, after the what? Negative 1 over 3x. You see where after the negative 1 over 3x, what comes?
Negative.
It's negative
1 over.
After the negative 1 over 3x, what comes?
Negative 2.
Yes. So before the negative 2 come here, you are going to put what? Before the negative 2 come, you add and what? Subtract negative 1 over 6 all squared. Are you seeing what I'm saying?
Yes.
So before even the negative 2 came, what did they came to do? They say because the rule said that what? Add and subtract. They came to what? Add and subtract the negative 1 over 6 over here. Okay. So at the end of the day, what they did is that this is what they had. They came to add and subtract negative 1 over 6, just this minus 2. It is still the same as what you are seeing over here. Okay, good. And then after this, take note that this negative sign over here is a red pen. If I say a red pen, I hope you understand. It is a boundary condition that should guide you to be able to do something. Don't confuse that for calculation. Okay, don't confuse that for calculation. So at the end of the day, we are coming to just take just first bracket and use and simplify it. If you take the whole of this, if you take just the whole of this alone, can you see that the whole of this is a quadratic equation on its own? I want to just figure out 1% for you to see something. Do you believe that the whole of this guy is a quadratic equation on its own again? The one underlined with green. Do you believe that it is a quadratic equation on its own? The one I underlined with green, that is the same thing over here again. Come again.
There's
Hello?
no.
I'm saying that the one I circle with green, I hope you can see it.
Yes.
The one I circle with green over here, do you believe that it is the same thing as the notes we are having over here? I wrote notes and I underlined something over here. Can you see this one?
Yes.
So the notes, You can see me using a green pen to circle something. That is what x squared minus 1 over 3x plus what, all into bracket, negative 1 over 6 all squared. Can you see that?
Yes.
And this whole equation is the same as what?
X minus.
Minus 1 over 6 all squared. Okay. Yes. Even if you
Okay.
put this into the calculator to, like you want to use the calculator to solve a quadratic equation, this is what you will still get. You will still get x minus 1 over 6. But my brother, today I want to tell you that after today, when you meet a quadratic equation question, you shouldn't shake anymore again. You see the first step, we repeated the question.
Yes.
And in the second step, what did we do? We just bring the coefficients out. Okay.
Mm.
In the third step, they say we should what? Divide the coefficients of x by 2. And also at the end of the day, let's square our result. At the end of the day, we are going to either add or subtract. And that is what we came to do in this step. Okay. All right.
Okay.
After that, I circle something with just green pen. What I circle with green pen, eh?
Mm.
Anytime you meet something like this,
Mm.
anytime you meet something like this, just maintain x, okay, and bring
Okay.
the sign minus, okay, the c. What is the value of c over here? The one I,
Negative.
the one I use x to circle, what is the value of c? The one I use green pen to circle, what is the value of
Neg
c?
Negative 1 over 6 squared.
The value of c is yes, 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 yes. So anytime you meet something like this, anytime you meet a quadratic equation like this, always know that your quadratic equation is just going to be equal to what? X minus what? C, all into bracket what? All squared. Do you believe me from this finding that I'm trying to discover for you?
Yes, please.
So there is no need to go to solve again. Anytime you meet a quadratic equation like this, always once you're able to remember the formula x minus c, it means that is the x for the x is in the equation, so it is easy to remember. But the c is the what? Intercept on the y-axis, and the intercept on the y-axis is what? Negative 1 over 6 all squared. Okay, so when you put that over there, you realize that at the end of the day, when you come and solve this one too, when you come and solve just this one, when you input this one in the calculator, you're going to get what? Negative 73 over what? 36. Okay,
Okay.
finally, this is the same as this. And you realize that the least value occur when x is equal to what? Negative 1 over 6. When x is equal to what? 6. Hence, the minimum value of x is negative 73 over 12, which occur at 1 over 6. Please, do you have any question to ask before we proceed? Do you have any
Well, how
do you have any question to ask before
the
we
fact
proceed?
how they've done it in a fraction from
Don't
that sort?
worry, don't worry, don't worry. You just drink water. And if you have water beside you, drink water and take a deep breath. Okay? Yes. The question is using your book. The book you are using is using a complex approach. I'm going to break this down and use a very simple approach, and you realize that, this formula, you will never use this formula in your life again. Always, you'll be using the simple approach that I'm going to teach you. Okay, good. So that is how your book has explained it, and I'm just trying to explain it in terms of your book so that you see what is happening over there. You say you didn't understand how they had what?
No, I said how it is in a fraction form. That's what's confusing me.
How is in a fraction form? That is what is confusing you.
Yes.
Okay, you don't worry. So that is what your book is saying. Okay, let's also come to the notes I prepared, and let's see how we can understand quadratic equation. Quadratic functions are polynomial functions of degree 2. If I say degree, it means they have the exponent of 2. Typically written as what? F of x is equal to what?
X
Ax.
squared.
Yes, ax squared plus what? Bx.
Yes.
What you are seeing over here. And I told you that it should what? Never be equal to what? 0, because once it's equal to 0, what is going to happen?
Some linear function.
Thank you very much. So once it is 0, it's going to become a linear function instead of being a quadratic function. Their graph forms parabolas, which can open upwards or open downwards. Okay. And all depends on the coefficients. That is why they are saying all depends on the sign A. Don't get confused by that too. Okay. The ability of the graph being concave or diverging depends on what the coefficient, which is the coefficient of x squared, which is a. Yes. So the key features of a quadratic function, just have a look. This is the general form of a quadratic function. I told you that quadratic functions are of this form, and they are in the form of what? A plus B plus C. So now can you see where the C is?
Yes.
Yes, I will just solve some example, and you were not able to see this. The C in that example was what? Just -1/6. That is just the C. Okay. Uh-huh.
Okay.
Also, I told you that you should always make sure that your A is never equal to what? 0. Otherwise,
Zero.
the function is going to become linear. Take note, the shape of a quadratic function is always a parabolic curve. But if the shape of a quadratic function is a parabolic curve, it means that the shape of a linear curve or the shape of a linear curve is always going to be straight. Okay. Parabolic means that the thing has curve. I taught you physics. What is when we say something has perform a parabolic path, it means the thing can be assumed to be under projectile, right?
Yes.
Uh-huh. An example is, can you give me an example of a of a parabolic path?
Example.
Yes, give me an example of an object that is taking a parabolic path.
Plane.
Thank you very much. So that is a correct example. Okay. And even someone who is jumping into a swimming pool, it can also be called a parabolic path. The person is the motion of the person is displacing a parabolic path. All right, all right, all right, all right, all right, all right. So if a is greater than 0, then the parabola opens upwards. Okay. And also if 0 is greater than a, then it also opens downwards. Let's look at the vertex. Okay. Let's look at the vertex. Okay. The vertex is the turning point of a parabola. Okay. And it is found using this formula. Okay. Listen to it one last more time again. The vertex, okay, the vertex is the hot turning point of a parabolic curve, and it is calculated for using the formula hot x at v. Okay, using the formula, your x at v is equal to what? Negative hot b over hot 2a. Write this formula somewhere. Minus 2 over hot minus b over 2a. All right. And also to know the axis of symmetry, a vertical line through the vertex A is going to give us what? B, negative B over 2A, the one that I just taught you, okay?
Okay.
To know the axis of symmetry, a vertical line through the vertex X is going to give us what? B over negative 2A. Now, we want to talk about the domain and range. For the domain, all real numbers, it means that in calculation of quadratic functions, the domain and range in which it lies is what? All real number. If I say real number, it means that 0 is not part of. Uh-huh. And the range also depends whether the parabola opens upwards or downwards. And what will determine whether the parabolic curve is going to open downwards or upwards? Hello?
Hi.
What is going to determine whether the parabolic or what is going to determine whether the parabola is going to open upwards or downwards? Can you quickly tell me that? You
Is
forgot.
that the range?
It is the coefficients, okay? The coefficients is what is going to determine whether the curve is going to open downwards or what? Upwards. Then the coefficient, which is what? The A I've been telling you about. AX plus what?
Mm.
BX, okay? Plus what? C. So if the coefficient is negative, is the curve going to be minimum or maximum?
Negative. Minimum.
If the coefficient is negative, the curve is going to be what? It's going to be a maximum curve. Okay. You are forgotten so soon. Come back to this diagram. Okay.
Ah,
If the coefficient
the
is what is negative, then it's going to what? Be a maximum
maximum.
curve. Okay. Don't get
Okay.
or don't misunderstand that for this. Okay. If the coefficient is negative, then it's going to be a what? A maximum curve. Let's come and look at this maximum value and minimum value. If A
Mm.
is greater than 0, it implies that it is a what?
Minimum
If A is
value.
greater than 0, if A is greater than 0, it means that A is what? positive. Okay.
Mm.
And also,
Okay.
if A is less than 0, it means that what? A is what? Negative.
Negative.
Okay. So A being negative, you see that that's why they are saying it's going to be maximum. And this one is going to be what? Minimum.
Mm.
You see? All right. At this stage, we have gotten to, I want to ask you one simple question. Online class and face-to-face class, which one do you enjoy far better?
Online.
And why do you enjoy online better than face-to-face?
See, this one I'm comfortable. That one, this one, yeah.
All
I
right.
get time.
Come again.
This one, I get time to do this thing.
You get time to do what?
Like I get time to understand small, small.
So when I meet you in person, you don't understand, or the pressure is too much.
Yes.
Okay. So you just mentioned a vertex, and I would just want to tell you that a vertex is a fundamental concept in geometry and mathematics. Okay. Its meaning depends a little on the context, but the core idea is always about a corner or point where things meet. Okay. So point where things meet can be known as the vertex. Okay, so look at an example of a quadratic function. And this function look in the form of what? F of x is equal to what? There is a
So,
over there. And what is the value of a? The value of a is what? 1. So ax squared plus what? 3x
yes.
plus c. And what is the value of c in this equation? Tell me the value of c in this equation so that we proceed.
2.
Thank you very much. So you can see that this graph is an upward parabola. Okay. If
Okay.
they say it is an upward parabola, is it going to be curve? Is it going to be concave or divergent? Is it going to be concave or divergent? Or is it going to
Yes.
point upward? Because here is positive, it should tell you something. Okay.
Yes.
Because here is positive, it's going to be what? Minimum. Do you understand me? And the second
Yes.
one, because here is negative, is going to be what? Maximum.
Maximum.
You see? This is the first thing to be able to what? Even identify before you solve the problem. And this one is simply going to be what? Is going to point upward. And that is what they mean by what? Upward parabola. It's trying to tell you that the curve is going to point upward. This part, okay, is going to point
Also.
upward. You understand me?
Yes.
Uh, so it is English. That is why I'm saying that you should be from this stage, start listening to music that are more of English so that it can sharpen your understanding. If you are still listening to songs that are of chi 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 ewe ewe ewe, it will affect your school life. Oh. So everything you'll be doing, let it be more of English. Okay. Let's look at real life.
Okay.
Let's look at real life application of quadratic functions. Okay. And quadratic
Okay.
functions. The reason why we are learning quadratic function, someone may be saying that, oh, this one is not important. Why are we learning this thing? You see, but after learning some of this topic, you realize that in physics, especially in projectile motion, such as what, rocket path or ball trajectories, this concept is being applied. Is it true or not? When you and I were learning physics, you remember that we were making references to projectile motion, right? And the concept came from quadratic function. Also in engineering, like structural design and optimization of problems, like the course your brother is reading now, the concept of quadratic function is adopted over there. Okay, we draw graphs whereby we encounter that some curves are parabolic and all that. Without knowing this, you won't be able to what? Do that course. In too many times, the link is going to go off. You just have to click it and be able to join back again. Also in economics, okay, profit maximization and cost analysis is done by what? This quadratic function that we are learning. So without knowing this topic, you can also be a good economics, okay? And even in biology, it is used to study growth models and what? Population what? Studies, okay? Very soon, you're going to be treating that topic, but it is a Form 3 topics. And also, why do you think quadratic functions matter in real life? Why do you think quadratic functions matter in real life? Good. Quadratic functions are fundamental because the model, because one, it helps in optimization. That is finding what your maximum and what minimum value. Okay. It helps in optimization. It helps you to know your maximum and minimum value. It also helps to provide a fundamental or higher level of mathematics like calculus and what differentiation. So if you know this topic very well and you go and you are studying what calculus and integration, you realize that life is going to be much more easier. But without knowing such things, you struggle. Okay, your friend, I placed a quadratic equation on the board for him the other day. He was facing challenges. It was due to some of these things because his foundation in quadratic equations were weak. He couldn't even simplify a simple calculus. That was the cause of that. He couldn't simplify a simple calculus. If he knew quadratic function, he could have applied that rule and he's gone. Okay, yes. So in short, quadratic function describe parabolic relationship that uh, in short, quadratic function describe parabolic relationship, okay, and are easy to recognize by squared terms and essential in both theory and real world problem solving. In real world problem solving. So the link is going to go off